Okay, so I'll be using this example to explain the mechanics of Dijkstra algorithm, and the nature of these questions usually revolve around finding the shortest path from 2 points. So in this case, the context is find the shortest path from Nick here to home, right? So the first step is to box this up and realize that I have 2 options from here. Following that, I know it takes, from Nick, it takes 6 steps to get to A. So I represent that in the brackets. From Nick, it takes 8 steps to get to D. Right, so that's how I represent my working. So between the 2 options, 1 and 2, A is clearly the shortest. So I'm going to box A up. So now that I've boxed A up, I can chart my path from here to here, right? So then from A to B, from A, it takes 10 steps to get to B. And from A, it takes 14 steps to get to E. Okay. So what are my options? I have 1, 2, and importantly, we have 3 here from before. So which one is the shortest? That would be D. Box this up. So now that I've boxed it up, I can chart my path here and here, right? So from D to say F, take 16 steps. From D to E, takes 10 steps. And since 10 is more optimal than 14, I'm going to cancel this out. So which one is the shortest? I mean, I can choose between this or this or this, but since 10 is clearly the shorter option, I can choose E. It's fine if you want to choose B. It doesn't matter at this point. But for now, I'm going to use E. So from E, I need to chart my paths from here to here. Yeah, that's it. So let's see E to C, right? From E, it takes me 5 steps to get to C. And from E to F, it takes me 5 steps too. So that's more optimal. Cancel this. So what are my options? I have 1, 2, 3. So option 2 is clearly, option 1 and 2 are optimal. So I can choose between either of them. I'm just going to choose F for now. So from F, I can chart my path here. And that gives me, from F, it takes, there's a missing number 6. Yeah, so from F, it takes me 6 steps. So what are my options? I have 1, 2, and 3. So the optimal path is C, right? So we didn't choose C earlier, but now we get to choose it. So it doesn't really matter which one we chose earlier. At some point, we will have circled back to C again. So if I choose C, I need to chart my path. So possible here, here, or here. Okay. So from C to home takes me 12 steps. From C to G takes me 9 steps. C to A, it's 10 steps. Okay, so what are my options? I have 1, cancel. Since C to G is not optimal, cancel it. I have 2, and I have 3. So which one is the most optimal path? it would be G, right? So I box G up, get rid of my working. So from G, I can go to home. That's my only real path. So from G, it takes 8 steps to get to home. Since this is optimal, get rid of the previous one, box home up, and I'm done. So I've boxed up most points from Nick to home. What I have to do now is to work backwards to find the optimal path, the shortest path. So starting here, it tells me to go to G, right? So I'm going to trace my line back to G. From here, it tells me to go to F, so I'm going to go to F. And at F, it tells me to go to E, tells me to go to D, tells me to go to N. And there you have it. So that's the shortest path. And if you were told to calculate the distance of the shortest path, it would be 8 plus 10 plus 5 equals 37, steps or meters.